ALS 046, defining old growth forests with airborne LiDAR. Forests in their later stage of development attain attributes that support biodiversity and provide a variety of benefits to human populations. Despite their irreplaceable values, old growth forests are declining worldwide due to anthropogenic pressures. Conservation approaches to maintain old growth forests do exist, such as Old Growth Management Areas, OGMAs, in British Columbia, Canada. Currently, OGMAs are mainly defined by estimate of forest age. However, it is uncertain if this selection strategy suitably identifies forests with characteristics, attributes expected in old growth forests. In this work, we developed a range of old growth indexes that capture multiple forest attributes associated with old growth forests. We then developed a LiDAR-derived metric that we utilized from a random forest (RF) modeling framework to model old growth forest attributes across the landscape. We designed 3 RF models in classification mode using field estimate classes as response variables. 1. Age class, 54% accuracy. Unsupervised classification of old growth attributes. 2. With age, 69% accuracy. And 3. Without age, 68% accuracy. In addition, we designated 3 other RF models in regression mode with field estimate for stand age R2 equals 35%, an old growth index 5 with age R squared 71%, and 6 without R squared 71%. We found that both classification and regression models, age was not crucial attribute, as age alone were not well predicted in neither classification nor regression models. As well, we found that excluding age did not significantly reduce the overall model's performance. Based on a combination of model performance and simplicity of the models themselves, we selected a LiDAR-derived model, Model 6, to scale up the old growth index from plot to landscape level. Using this model, we found that 14.7% of the study area is converted by forests with high old growth values. Inside the currently designated OGMAs area, the old growth cover is 24.9%, indicating that OGMAs are retaining forests with some high old growth value. However, only 2.5% of the OGMAs have more than 50% of its area covered by forests with high old growth value. This research brings light to old growth and OGMA's definition and their assessment through the use of fine-scale remotely sensed data, LiDAR. More importantly, the identification of the amount of location of old growth forests over the landscape can avoid to the conservation of this rare resource and its services. ALS 051. Tree buffer exclusion can improve tree detection on airborne laser scanning surveys in even age stands. Individual tree detection, ITD, is one of the approaches to estimate stand attributes using LiDAR data. The most critical part of this approach is the actual detection of the tree or delineation of its crown. Because of that, many studies have been carried out to develop and test algorithms that correctly identify trees over different forest structures. Usually, for even aged stands, a simple local maxima filter would work, as the canopy structure is homogeneous. In spite of that, even under these conditions, the number of trees is under or overestimated in many cases. This study tests an add-in for tree detection methods for even age stand application. We tested two software fusion and our LiDAR package local maxima filter algorithms, LMF, with 3 window size each, and the watershed approach. Afterward, we performed the tree buffer exclusion using radius from 0.5 to 2 meters. This exclusion consists of iterations over all the tree tops, creating a buffer, keeping the highest value and excluding the others that fall within the buffer. The results were compared to the number of trees found in the forest inventory. The area of study had 470 hectares of eucalyptus ranging from 3 to 6 years, divided into 19 stands with 2 different spacing, 3 by 3 and 4 by 3 meters. The LiDAR data was obtained from the Cessna 206 with a point density of 5 points per square meter and maximum scan angle of 30 degrees. The results indicate that the methods without buffer exclusion usually overestimate the tree density instead. For the local maxima filters, as the window size increases, the number of trees is underestimated with no mean near where the error equals to 0. With the tree buffer exclusion, it was possible to obtain errors ranging from 0.9 to 25%, with a relative RMSE percentage of 13.38%. All methods were improved using the tree buffer exclusion. The best overall method was using Fusion's local maxima filter with a 2 meter window size and a 1.5 meter buffer for tree exclusion. However, the best method was different if we analyze stand by stand. That might be explained for the difference in age, slope, spacing, and scan angles of the stands, which might be explored in further studies. ALS 069 Rethinking Accuracy Assessment Standards for LiDAR Models Predicting Forest Variables. The accuracy assessed for model-assisted LiDAR predictions of the forest variables usually lacks an external validation carried out with an independent dataset. The reason it is not only the high costs of field data acquisition, but also the fact that dividing the available data into 2 separate groups, one for training and another for validation, inherently leads to a loss of statistical power. Consequently, cross-validation methods are typically used in this context for calculating and report mean absolute differences, root mean square errors, and coefficients of determination between observed and predicted values. In this research, we wanted to put into question the sufficiency of these common procedures, suspecting that they may eventually conceal cases when the model are in fact overfitted to the sample. To demonstrate this end, we employed an argument of the type reduction ad absurdum, showing models clearly unreliable, including an unrealistic number of predictors, which could nonetheless be taken for good in light of these common metrics for accuracy assessment. We then investigated the convenience of including in the assessment a measure to avoid overfitting, which consisted of limiting the inflation in the sum of squares observed in the cross-validation as compared to the overall model fit. Results show that overfitting can in general be avoided without greatly compromising model precision. effectively yielding more reliable maps at the high resolution delivered by LiDAR. Harmful effects of overfitting lay not just in lack of model generality, but also a tendency to predict towards the average. For example, systematically underestimate high values and overestimate lower ones, which is difficult to detect because it leads to an unbiased mean estimate, yet rendering the resulting maps with many false predictions at the pixel level. Further research should focus on how these overfitting effects can be prevented using different cross-validation settings. While we focus on our research on the prediction of qualitative variables, we suspect that classification models may be as affected by overfitting and thus recommended similar research to be carried out for typical measures employed in the evaluation of contingency tables such as kappa coefficient.